Section 7.2, multiplying and dividing radicals. We're going to talk about multiplying radicals first. Now, with these bases, you might want to take a minute to pause the video, and then I would write down the stuff that I have written up here, and then you can listen. So to multiply radicals, they must have the same root. How do you multiply radicals? You multiply them if they have the same root, or that means the same index. So same root, or I'm going to write in parentheses, index. Then you multiply the number underneath the radicals, and then you simplify it. Remember that simplified radicals means no decimals, no fractions underneath the radical, and no radicals in the denominator. So that's a pretty big thing that we need to remember about simplifying radicals. If I look at this first example, notice that the index, when it's not written, is 2. So in this case, we have the square root of 2 times the square root of 8. Since the index is the same, we can go ahead and multiply what's underneath the radicals together. So this is the square root of 2 times 8, and the square root of 2 times 8 is equal to the square root of 16, and we know the square root of 16 is a perfect square, and that is equal to 4. If it did not give me a perfect square, then I would use those rules that we learned the other day in order to simplify my radical. So if I look at number 2, notice that the index is 3 for both of them because we have a 3 here and here. So what I do is I'm going to take that, keep my index, don't forget to write that 3 there, and I have 3 times negative 9. So 3 times negative 9 is going to be the negative 27, and don't forget to write the index is 3, so it's a cube root of negative 27. And then, of course, we showed in the calculator how you can find this, or you have to think what times what times what would give me negative 27, so negative 3. And again, if you need to use your calculator to help you do that, that's fine. So for number 3, now if we look at this problem, we have the fifth root times the fifth root of something. So since the index is the same, we can go ahead and multiply them together. So I'm going to multiply what's underneath all together. So we get 16 times 2, which is 32, x to the fifth, y to the 15, and remember this is the fifth root. So now I'm looking for groups of 5 because that's my index. If you do the fifth root of 32 in your calculator, remember we showed that yesterday, that's going to be equal to 2. How many x's can we take out? Well, we have one group of 5 x's, so that means we can take out 1 x, or 5 divided by 5 is 1. And then we have 3 groups of 5 y's, so that means I can take out y to the third, or 15 divided by 5 is 3. So 2xy cubed. Now, let's talk about simplifying radicals. How do we simplify radicals? So we've already done this, but remember you want to have no decimals, no fractions underneath the radical, and no radicals in your denominator, which we're not doing dividing yet. So you make a factor tree, circled factors according to the index, circle go outside the radical, uncircled stay underneath, multiplied underneath your radical. So if you look at number 1, we have the square root of 72 x to the third. So the index here is 2, even though it's not written. Now 72, the square root of that, doesn't give me anything nice. That means I need to make a factor tree. Now it doesn't matter what numbers you pick. Usually people try to look for perfect squares, or you can do, like I said, pick any number. So I'm going to do 9 and 8. And I know that 9 is a perfect square, which is 3, or if I want, I can break it down 3 and 3. 8 breaks down into 4 times 2, and this breaks down into 2 times 2. So I'm looking for groups of 2 because my index is 2. So I have a group of 2 3s and a group of 2 2s. So that means on the outside of my radical, I know I'm going to have 2 times 3, because you always multiply the numbers. And then underneath the radical, I have leftover right here. This one was not circled, so that stays underneath. So that would be 2. Now if I look at my x's, I have 3 x's. So if I wanted to, I could write out x times x times x. I have one group of 2 x's. That means 1 goes on the outside while 1 stays underneath. And then if I simplify this, 2 times 3 is 6x times the square root of 2x. And that would give me my solution. So then if you look at number 2, the difference with this problem is that we have numbers on the outside. And we're multiplying 2 radicals. So the 2 radicals have the same index, so that means we can multiply them underneath. So 8 times 3 would be on the outside. and then I have the square root of 6 times 4. So then if I do this, I get 24 root 24. The square root of 24 is not a perfect square, so that means I have to use my factor tree in order to break it down. So we already know this is 6 times 4, and this breaks down into 2 times 3, and this one is 2 times 2. So this right here would give me a group of two twos that I can take out. 2 and 3 don't have any groups of 2, so they're going to stay underneath as 6. So when we simplify this, we have 2 on the outside times 24 times the square root of, and then remember we said that 2 times 3 was left underneath, so 6. And 24 times 2 gives me 48 root 6. So let's look at number 3. Let's see, I would pause the video and see if you can do this one on your own and then unpause it. For number 3, we do the same thing. We have the same index, which is 2, so then I'm going to multiply what's underneath. So when I do that, I get the square root of 50. And remember when we multiply variables, you add the exponents if they have the same base. So this would be a to the 3 plus 2, which is a to the 5th. And then you have b to the 2nd power, because this is b to the 1st plus b to the 1st. So 1 plus 1 is 2. And then c squared. And then because the square root of 50 is not a perfect square, that means that I want to use my factor tree to find groups of 2, because the index is 2. So this would be 5 times 10, and this breaks down into 5 times 2. So that means right here I have a group of 2 5s, so that means one of those goes on the outside. Notice the 2 is uncircled, so that stays underneath the radical. So I get 5, and let's do the variables before we do our radical. So index is 2. If I have a to the 5th, that means that I can take out a squared. B to the 2nd means I can take out 1b, because that's a group of 2 b's and a group of 2 c's, so this would be b, c. And then underneath my square root, I'm left with 2, and then I know that a squared, 2 times 2 would be 4. That means I have 1 left over. Or if it helps to write it all out, a 5 times, you have 1 group, 2 groups, that's why it's a squared on the outside, and 1 left underneath the radical that's uncircled. Now what happens when the index is not 2? When the index is not 2, then we're going to have to look for the groups according to what the index is. So if you look at question number 4 here, the index is 4. That means I want to look for a group of 4. So for this first one, I'm going to factor it down or break it down. So I know this breaks down into 8 times 10, and 8 breaks down into 2 times 4, and 4 breaks down into 2 times 2, 10 breaks down into 2 times 5, and again I'm looking for a group of 4. So if you notice, this 2 here, here, and here, that makes one group of 4, and the 5 is uncircled, so that's going to stay underneath my radical. The 2's go on the outside, or just 1, 2 goes on the outside. So this is equal to 2, and then I'm going to do my n's. So I have n to the 5th. That means how many times does 4 go into 5 evenly? Once. So n, and then the square root of, we had 5 left underneath, and then 1n, because 4 went into 5 once with 1 left over. And if it helps you to write out all your n's and then circle them and do it that way, that's fine too. So 1, 2, 3, 4, 5. So we had one group of 4 n's, and then one that's underneath your radical left over. So then let's look at number 5. So for number 5, the same thing, except for we have cube roots being multiplied. So cube roots being multiplied means that we can multiply them underneath one big cube root radical. So 3 times the 45 gives me 135. And then x squared times x to the 4th, add the exponent. So that's x to the 4, 5, 6, z to the 6th as well, when you add the exponents. Now 135, if you try to take the cube root of it in your calculator, you don't get a nice number, which means that you're going to have to make a factor tree. So when you make your factor tree, I already know that 3 times 45 is what I'm going to use, and then 45 breaks down into 9 times 5, 9 breaks down into 3 times 3. My index is 3, so I'm looking for a group of 3. I have a group of 3 3s, and 1 5 that's prime that's left underneath. So when I do this, I get 3, and then my power here, 6 divided by my index is 3, so 6 divided by 3 gives me, not 3, 2, 2, so x squared, and then this would be z squared, and then underneath my radical, I'm left with that 5. So this would be my solution. So I would see if you can do number 6 on your own, and notice that you have those numbers on the outside, so you would have to multiply the 3 times negative 2 on the outside and then everything else underneath your radical. Now we're going to talk about the next thing, which is dividing radicals. And well, before I do that, I should go back here, and I forgot to write up the property that we have when you're multiplying something with the same index. So this would be if you have the nth root of a times the nth root of b, that's equal to the nth root of a times b. That's the property. So dividing radicals, we have the property, if you have a big radical and the nth root of a divided by b. Now, we don't like to have fractions underneath of a big radical like that, so we have to simplify it. So there's a couple of things that you can do to simplify it, which we'll talk about, but we can separate this into the nth root of a over the nth root of b. Oops. And again, remember we said when we're simplifying radicals, we don't like to have radicals in my denominator, so then we would talk about how to get rid of that radical in our denominator, which we'll do in a little bit, but that's the property that you need to know. So if possible, you want to simplify the fraction inside the radical first. If you can't simplify and are left with a radical in the denominator, you must do what's called rationalize. Here. I'm going to run out of room writing there, so I'm going to write it up here. So rationalize. So you must rationalize the denominator. What rationalize means is that you don't want to have any radicals in the denominator, so that's what that means. So to do this, you multiply the top and bottom by the radical to make a perfect square, a perfect cube, or whatever the index is in the denominator, and then you're going to simplify using the rules that we talked about. So if I look at number 1, I have a fraction underneath a radical, which I can't have. And notice that 36 over 25 does not simplify. Since that does not simplify, that means I'm going to use my property of radicals and separate this. I'm going to do the square root of 36 over the square root of 25. Now, the square root of 36 and 25 are perfect squares, so I know that this ends up being 6 over 5. So that's kind of a nice one. If you look at number 2 here, for number 2, I have the cube root of 32 over negative 4. So the first thing I would try to do is see if I can simplify 32 over negative 4, which I can. This becomes the cube root of negative 8. And then I already know that the cube root of negative 8 is negative 2. If you didn't know that, you can use your calculator and punch it in to figure out what it's equal to. And so negative 2. For number 3, notice we have variables in our equation. So first things first, I would see if I can simplify this. So 4 over 16 simplifies into 1/4. So I have root 1 over 4. And x to the 4th over x to the 4th, remember when you're dividing two things with the same base, you subtract the exponents. So this would be x to the 0. And remember, anything to 0 power is 1, and 1 times anything doesn't change it, so we don't really need to write that in our problem anymore. So 1/4 doesn't simplify anymore, so this would be the square root of 1 over the square root of 4. The square root of 1 is just 1, and the square root of 4 is 2, so this simplified into 1/2. So now let's look at a couple more complicated problems. So number 4 here. For problem number 4, I have root 7x over 35x to the 3rd power. So first things first, you want to simplify this. So I know that 7 over 35 is going to give me 1/5. And if I have x over x cubed, so I'm going to do that up here. So x over x cubed is equal to x, and then you do 1 minus 3, which gives me x to the negative 2 power. Remember, we don't like negative exponents, so that's really 1 over x squared. So that means x squared goes in my denominator. Now, since I can't simplify anything more and I have a fraction underneath my radical, I want to separate it using my properties. So the square root of 1 over the square root of 5x squared. I know the square root of 1 is just 1, and I can take out an x because I have an index of 2 and a group of 2 x's. So this would be 1 over x times the fifth root of 5. Now, there's nothing else that I can do to simplify this because we don't have the square root of 5 and I can't break it down using what we learned on the other page. So I cannot leave my answer like this because we don't like to have radicals in my denominator. So that means that I need to get rid of it. In order to get rid of it, I like to multiply what I call the magic 1. Because remember, anytime you multiply something by 1, it doesn't change your equation at all. So I have to think about what's going to help me get rid of that radical in my denominator and not change my equation. So remember, we said the index here is 2, and in order to get rid of a radical, I have to have a group of 2 things. So if this is 5, that means I need one more 5 to make it a group of 2. So I'm going to multiply this by root 5 over root 5 because that's like multiplying my equation by 1, which doesn't change it. So in how do you multiply fractions? Remember, you multiply numerator times numerator and denominator times denominator. So 1 times this 5, root 5 would just be root 5. Over, and then I get x, and then root 5 times root 5 becomes x times the square root of 5 times 5 is 25 because I have the same index. And notice that I did that on purpose because the square root of 25 is really 5. So I get root 5 over 5x. And now I have no decimals. I can't simplify anything further, and there's no radicals in my denominator and no fractions underneath my radical. So that's as simplified as far as I can get. So let's do maybe off to the side one that might be a little bit easier. So I'm going to do another problem up here that's, again, a little off to the side. Actually, let's do it on a separate sheet of paper. If I have 1 over the square root of 3. Now, I can't simplify anything here as it is, but I have a radical in my denominator, which I can't have. So I need to get rid of that. So since the index is 2, I'm going to multiply by the root of something over the root of something. Well, if the index is 2, that means I need a group of 2. I have 1, 3 here, that means I need another one. So root 3 over 3 is like multiplying by 1, so it doesn't change your equation. And then you can multiply numerator times numerator and denominator times denominator, which would be the square root of 9. And we did that on purpose because that becomes 3 over 3. Now I don't have any decimals, I don't have any radicals in my denominator, and I don't have any radicals or any fractions underneath a radical. So that's simplified. So let's do another one. Let's say instead that we had a cube root of something. So let's say I had 1 over the cube root of 3 instead. Now, my magic 1 is not going to be root 3 over root 3. It has to be the cube root over the cube root because remember, you can only multiply radicals with the same index. And since the index is 3, that means I'm looking for a group of 3 3's in this case. So I'm going to multiply by 2 more 3's. So 3 times 3, and 3 times 3 is 9. So I could have really written 9 right here if you want to. So in my numerator, then I end up with the cube root of 9, which doesn't simplify, over the cube root of 3 times 3 times 3, which is 27. And that gives me the cube root of 9 over 3, which we did on purpose, and then this would be my simplified answer. So let's do one more. Let's say I had 1 over the fourth root of 2. So if I have 1 over the fourth root of 2, I'm going to multiply this by my magic 1, which has to be a fourth root over a fourth root. Since it's a fourth root, I need a group of 4 2's. I have 1 here, which means I need 3 more. So 2 times 2 times 2 times another 2 would give me 4 2's. So 2 times 2 is 4, and 4 times 2 gives me 8. And you can put that there, or you could put 8 right here if you wanted to. So this times this gives me my numerator, the fourth root of 8, which does not simplify, over the fourth root of 16. And we did that on purpose because the fourth root of 16 gives me 2 for my answer. And then this would be my simplified version. So that's what we're doing when we're rationalizing our denominator. So let's go back to that paper that we had. If I look at question number 5 here then, now notice that I can't simplify anything. I have the cube root of 5x squared. So I need to multiply this by the magic 1 to rationalize my denominator. So what is that magic 1? It has to be the cube root of 3 over the cube root of 3. So I have 1 5. That means I need 2 more. And 5 times 5 is really 25, so I'm just going to write that there. And I have 2 x's. That means I need 1 more. And so that's what I'm going to multiply my numerator and denominator by. So in my numerator, I get the cube root of 25x, which does not simplify, over, in my denominator, 5 times 5 times 5 would actually be the cube root of 125, and then x squared times x would be x cubed. The cube root of 125 is really 5, and the cube root of x cubed is just x. So this right here would be my answer, and I can't simplify that anymore. I can't do anything with those x's because that's underneath a radical in your numerator, and the denominator is not underneath a radical anymore. So why don't you guys see if you can do number 6 on yourself by yourself. So I pause it and then restart it. So looking at number 6, if I made this one big fraction, 11a over 3 doesn't simplify to do anything, so that's not going to help me. So that means that I can't have that radical in my denominator, so you need your magic 1. So what would be the magic 1 here? I need a square root and a square root because it's a square root here, and that means that I have 1 3 and I need 1 more to make a group of 2. So my magic 1 in this case is going to be root 3 over root 3. Remember, multiplying by 1 doesn't change your equation. So if you have radicals with the same index, you can multiply them underneath. And then root 3 times root 3 is root 9, which is really just equal to 3. And then this does not simplify any further. Okay, so let's go ahead and go to, instead, let's go to number 9. So if we look at number 9 here and continue, so for question number 9, I would do the same thing. Can I simplify what's underneath the fraction first? In this case, yes, I can. 186 over 6 gives me 31, so this becomes the square root of 31. X over x to the fourth would be x to negative 3 when I subtract the exponent, so that means it goes in my denominator. And for this one, I can't simplify that any further, so I'm going to make this the square root of 31 over the square root of x to the third. I can simplify the square root of x to the third because I need a group of 2 that I can take out, which I have. So this becomes root 31 over x times the square root of x. I still have a radical in my denominator, which I can't have. That means I need to multiply this by my magic 1, which would be root over root. I have 1x here. I need 1 more to make a group of 2. So I'm going to multiply by root x over root x. When I do that, in my numerator, I get the square root of 31x over, and then this times this gives me root x squared, which is really just x. So then I have x times another x, which gives me x squared in my denominator. I can't simplify that any further, so this would be my solution. So I'm going to give you the answers to 7 and 8, and I would try to see if you can do those on your own. So the answer to number 7 is the square root of 4x squared over 2x, and the answer to number 8 would be the cube root of 75ab squared over 5ab. And again, the main thing to remember is what you need to do in order to simplify these radical equations. So remember, simplifying radical equations means no decimals. It also means no fractions underneath the radical and no radicals in your denominator.